before we move on to coterminal angles, one important thing that's worth noting is when we express angles in radians, since radians are real numbers, there's really no need to write that RAD abbreviation at the end. But if you are expressing angles in degrees, you definitely need to write the degree symbol, right? So for example, if something was in degrees and you wrote 180, that would be interpreted as 180 radians, not 180 degrees. So when you're doing degrees, you need to use the degree symbol. But with radians, not so much. You don't need to actually write radians because they are, in fact, real numbers. Because you can think of them as distances, right? They can be measured, just like real numbers can be measured. So standard position and coterminal angles. So the thing that we did talk about a little bit in the last video was standard position, right? Standard position meant that the initial side of the angle was the positive x-axis. So you can see these pictures here, all four of these angles, right, have the initial side as the positive x-axis, and they just show the various terminal sides of these angles after going through a rotation. So this one, you rotated counterclockwise a bit. This one you rotated clockwise. This one you rotated counterclockwise. And this one you rotated counterclockwise. This one actually, these last two in fact, you rotated more than once around the circle before ending up at your terminal side, right? Here you actually rotated one complete time and then more than half of another time. This one you rotated one complete time and then a little bit of another time. Now, again, talking about positives and negatives, the first one, the third one, and the fourth one would be positive angles, right? Because you rotated counterclockwise. This one here would be a negative angle. However, I could have also, in the second one, for example, rotated counterclockwise and ended up at the same place. And that would actually have been a positive angle versus this one being a negative angle, but they have the same terminal side. So another concept that we're going to start talking about here is this whole idea of coterminal angles. Coterminal angles actually have the same terminal side, but they might have different measures. Just like these two here that I just drew in now in this second diagram, right? This one was a negative angle, that one was a positive angle, but they both ended up in the same place. Therefore, those are coterminal angles. Now here, coterminal angles really, they kind of bring out the point that drawing that red rotational spiral with the arrow on the end is important to differentiate between angles, because with coterminal angles, if you don't draw that, you don't know which angle you're talking about, right? You might be talking about a positive angle, you might be talking about a negative angle, you might be talking about one that wrapped around the circle completely once before getting to the terminal side, or twice, or three times, or any number of times. So what they do in these following diagrams here is they just illustrate coterminal angles, right? So here you have a 30-degree angle. That was just a short rotation counterclockwise from the positive x-axis up to 30 degrees. Here you have a coterminal angle that actually wrapped around the circle one complete time and then ended up at the same point. And that's actually a 390-degree angle. So 30 degrees and 390 degrees are coterminal angles. And then here you have a third angle that didn't go counterclockwise but went clockwise, but still ended up at the same terminal side. And this was actually an angle of negative 330 degrees. So 30 degrees, 390 degrees, and negative 330 degrees are all coterminal angles. So what you should see from this first picture here is, how do you get from 30 to 390? Well, 30 to 390, all I basically did was add 360 degrees, right? Because what am I doing when I'm adding 360 degrees? I'm just wrapping around the circle once. Okay? And then in the third one there, how did I get from 30 to negative 330? Well, I just subtracted 360 degrees. So in that case, what I did is I wrapped around the circle once clockwise, which is equivalent to subtracting 360 degrees. So I would eliminate that 30 there, and then I would, that would bring me back to 0, and then I would have another 330 left. But since I was going clockwise, it ended up being negative 330 degrees. Okay, and then a similar thing happens with radian measure, right? If I have a pi over 3 radian angle here, I can also wrap around the circle once and end up at the same place, and that would have been 7 pi over 3. Or I could have went clockwise, ended up at the same place, and that would have been negative 5 pi over 3. But it's the same idea. When it's still the idea of wrapping around the circle a complete rotation. So from pi over 3 to 7 pi over 3, what I really did here is I added one complete rotation, which is 2 pi. And then over here, from pi over 3 to negative 5 pi over 3, I just subtracted 2 pi. Right? This one, I mean, it's a little bit more complicated to see because you have to get a common denominator. But when you're adding pi over 3 and 2 pi, what you're really doing is you're saying pi over 3 plus 2 pi. Well, okay, I need a common denominator. So the common denominator would be 3. So 2 pi, if I write it over 3, is going to be 6 pi over 3. So then pi over 3 plus 6 pi over 3 is 7 pi over 3. Right? And that's how I got that one in the middle. And then you would do the same thing to get negative 5 pi over 3. You just subtract 2 pi. So then you get negative 5 pi over 3. So that's the idea. So what you're doing to create coterminal angles is you're either adding or subtracting 360 degrees if it's in degree measure, or 2 pi if it's in radian measure. So very simple. So if I want to find coterminal angles with 135 degrees, well, easy. What's 135 degrees plus 360? Well, that's just 495 degrees. So that's 495 degrees. And if I want to find another one, well, I could add another 360. But you generally want to find the ones that are, I guess, call it closest in measure to the given one. So 135 minus 360, and that would have been negative 225. I think that's right, right? Negative 225 degrees. So yeah, so you're just adding 360 or subtracting 360, and that's giving you the coterminal angles. And then the same thing applies with radians, except the difference now is that you're adding 2 pi. So if you're working in sixths, right, 2 pi is really 12 pi over 6. So negative 5 pi over 6 plus 12 pi over 6, that's going to leave you with 7 pi over 6 radians. And then if you do the subtraction, right, negative 5 pi over 6 minus 12 pi over 6, that's going to give you negative 17 pi over 6. So there's your two angles that are coterminal with negative 5 pi over 6, right? 7 pi over 6 and negative 17 pi over 6, right? I mean, I just draw a quick picture for one of them. Generally, I want to keep all these videos under 10 minutes. Otherwise, it gets a little tedious. So the picture for this first one, 135 degrees, well, that would have been here's my initial side, right? The positive x-axis, 135 degrees. Well, there's 90. And then 45 more is going to land you exactly halfway in that second quadrant, right? So that's 135 degrees. Now, what would be negative 225 degrees? Negative 225 would have been this one. And what would 495 have been? That's the one's trickier to draw, right? That would have been wrapped completely around once, and then 135 more degrees. So that was your 495 degrees. A little messy, But those are the three coterminal angles.